In all my DIY perfumery and obtaining aroma compounds, I was surprised to find that it's really easy to get hold of Dodecanol. This is almost half a kilogram. It's a solid unless you live in the desert, which I do, in which case it's liquid half the year. So when it arrived, it was mostly liquid. Mostly, but not completely. It's kind of hard to see in there, but this is almost all solid right now, it being November. Dodecanol is used to make surfactants, for example in shampoos. It's also known as lauryl alcohol, so anytime you see sodium lauryl sulfate, sodium laureth sulfate in ingredient lists for products used for cleansing, Dodecanol was involved in the making of the product. And that demand is why Dodecanol is available in quantity. This is supposed to have a floral aroma and, I don't know, I would describe it more as wet, dusty, kind of like a pond. It doesn't smell floral to me. For DIY perfumery, some of the ingredients, such as these aldehydes, like to come out of the bottle too quickly and overdose themselves in the recipe. To prevent that from happening, one thing I found useful is to dilute these ingredients with Dodecanol. It makes the liquid more viscous and also makes the scent less strong, so it takes more drops to overdose it. Yes, I use drops. Sue me. Aldehydes have to be diluted in ethanol anyway, which is not very viscous and drops way too easily. Dodecanol's scent is quite weak, so it doesn't significantly alter the scent of most perfume ingredients. Here we can see that because I've thickened these aldehydes with Dodecanol, it drops much more slowly than ethanol would, irrespective of the 5% of aldehyde. I had the wild idea to put some Dodecanol and some water in a sealed container. And you can see there's an air bubble in there too, which helps in case the water were to freeze, so that it doesn't break the glass from the inside. Although really, I suppose I could have frozen both liquids, then trimmed the excess off the top. Frozen Dodecanol is a waxy solid. Dodecanol melts just at the warm end of room temperature, 24°C or 75°F. It's less dense than water, so it floats on the top. It has a different refractive index, so you can see the boundary between the two liquids. The water actually forms a pretty significant meniscus, and I think that's because the water can form hydrogen bonds to the glass much more than Dodecanol can. Dodecanol can form hydrogen bonds as well, but it has a long aliphatic chain that makes it a hydrophobic substance. Right now it's warm enough in here, and I've been handling this container, keeping it warm, that both these compounds are liquid. But if I let this sit, the Dodecanol can freeze and form a white solid layer on top of the water. But then if I pick it up and handle it for a few minutes, it melts again. So I think this is a really nice feature of this stress reliever. I thought about putting something blue in the water, maybe some copper sulfate, and maybe even a tiny 3D printed 3D Benchy. That way it would look like water and air with the boat at the surface. It would have to be a very tiny 3D print, probably have to go resin print, which I am not equipped for. And the density of the print would have to be exact, not to mention the problem that a 3D Benchy will actually float upside down. So maybe I could dye the alcohol layer instead and have it be an upside down boat novelty, if I had the right kind of printer, which I don't. Different colors of liquid would look cool, but so does having them both clear, so I'm divided. If the room is too warm for the Dodecanol to freeze, you can always put it in the fridge, or maybe the freezer, but a refrigerator would certainly be cold enough and won't risk bursting the glass. This is the water and Dodecanol going into the freezer. I have to be careful because if I forget them in here and go to sleep, then tomorrow morning I'll wake up to a mess. Well, I didn't fall asleep and I didn't forget. And we've got some condensation on the outside of the bottle. But we've also got a nice solid layer of Dodecanol. So now I'm warming it back up in my hand and melting it again. I have the dodecanol completely remelted now. These two liquids are immiscible, but not completely insoluble in each other. Near room temperature, water is soluble less than 3% in dodecanol, and dodecanol is soluble less than 0.1% in water. So although the liquids won't mix, they are contaminated with each other. We can see some nice optical effects owing to that meniscus. From underneath, the bubble looks a little larger than it actually is. If I shake this up, I can create bubbles of water in the dodecanol, which now looks murky, while the water stays relatively clear. I've gone ahead and added a small amount of copper sulfate to the water. Alcohols and sulfates do not readily mix, so this seemed like a good choice. And this phone camera just doesn't want to focus. You might be wondering why I chose copper sulfate and not just food coloring. And the reason is food coloring comes from coal tar, and I'm worried it might leach into the hydrophobic layer. We can see the copper salt makes a nice pale aqua color. After letting the liquid settle, I'm seeing some kind of crud or gunk that's just hanging out at the boundary between the liquids. I'm a little disappointed, but I guess that's what happens when I use garden chemicals. Really, the copper sulfate should have been dissolved and filtered before using it to make this. This looks a lot bluer to the camera than to the eye. I was hoping it would look like a sea. It looks like a polluted sea. That's something, right? Filtration did the trick. I filtered the two liquids into a whole new container. I lost some of the dodecanol because it soaked into the filter paper. But that's okay. It means there's a little more room for what I want to do next. Ooh, wait till you see what I'm going to do next. It involves adding more water, so this is actually perfect. Both the materials are in a liquid state right now, and I'm in a well-ventilated area. And I have ammonia! Ammonia and copper salts do something really interesting together. Ammonia, being a base, first precipitates the copper as hydroxide. But as you add more ammonia, the reaction changes. Okay, why are you not reacting? The ammonia isn't going into the copper salt. What gives? Let's try injecting the ammonia into the aqueous layer. Now if I shake this with the cap on, we get a hydroxide precipitate. Now if I add more ammonia, and yes, the camera isn't steady because I'm paying attention to handling a dangerous chemical and not the damn camera, we see the deeper blue of the ammonia-copper complex. But something's wrong. Another thing I'm going to do is seal this cap. It's not very tight, and I can feel a thin layer of both liquids on the exterior of the glass. It looks like the ammonia reacted with the dodecanol. Here's our beautiful blue complex. But what was liquid dodecanol is now a solid. It coated the dropper. I've placed some of the blue liquid back into the bottle. As for the solid stuff, it's very solid. The camera shows it looking yellowish, but it's actually a pure white. At this temperature, it should be liquid. So I've got myself a little mystery. Well, I didn't solve the mystery of the reaction, but I did add fresh dodecanol to this bottle and sealed the cap. It doesn't seem to be reacting, and we can see the beautiful and cathartic way the two materials flow past each other. And just look at this really nifty reflection and refraction effect. Following my success with the stress reliever containing dodecanol and copper ammonium sulfate, my roommate wanted a similar stress toy made of tequila and coconut oil. And it's quite different from the other bottle. And my guess is that the two liquids in this case have similar densities, and that's why it's behaving strangely.